Welcome to Lecture 3.1, Named Functions for Introduction to Programming in Mechanical Engineering. By the end of this lecture video, you will have an understanding of what named functions are, how named functions versus anonymous functions differ, how to write named functions, how to determine good applications for using named functions, and how to apply a named function to the vector cross product. This slide, the table of contents, contains hyperlinks to each of the sections to make the downloaded PDF easy to navigate. Named functions encapsulate one or more operations to be extracted from the main body of code. They are usually defined in standalone files and can then be called from within the command window environment or from inside scripts. They are best utilized for modularizing larger portions of code with more than one line. Now, in the previous week, we discussed anonymous functions. It is valuable now to cover how these two different types of functions actually differ. Anonymous functions are stored as a variable within a script, whereas named functions are stored in a standalone file. Anonymous functions can only encompass one line of code. Named functions can encompass as many lines as you want. Anonymous functions are meant for simple operations. Named functions are used for complex, multi-step operations. Now that we understand what they are and a bit of how they're different from their anonymous siblings, let's introduce how to write a named function. The definition of a named function is wrapped by the keywords function and end as follows here. Then the inputs, the function name, and the outputs are specified as shown here following the function keyword. Note that the outputs are specified in brackets before the equal sign and the inputs are specified in parentheses after the equal sign. In the case that there are no inputs or outputs, you can leave one or both of those blank. And finally, the operations that actually make up the body of the function are written in between the keywords wrapper. Before we take a look at an example, note that the body of a function can only access variables that were either passed into it via the inputs in parentheses or that were defined in the body itself. And similarly, code outside the function cannot access variables defined within the function's body unless they are returned via the outputs in brackets. This is a concept called variable scope. It is very important to consider variable scope when you work with functions to make sure that you are keeping track of what information is actually accessible in different parts of your code. Consider a function that accepts two numbers as inputs and then prints all of the arithmetic operations between them. We set up the function and end keywords. There won't be any outputs for this, so the brackets are left empty. And we'll call our two inputs A and B in parentheses. The first operation prints the result of their sum. Note here that the \n is the new line character in strings so that in the print statement it will create a new line. The second operation prints their difference, then we print their product and their quotient, and finally their power. To use this function, it can be called by its name with its inputs passed in parentheses. In the command window, we write print arithmetic with 3 and 4 in parentheses as the two inputs A and B. Then each result is printed line by line. Named functions are useful, just like anonymous functions, for extracting repeated operations, or to make code more readable and simpler to debug. But unlike anonymous functions, they can encapsulate more than one line of code. This makes them great for extracting operations that involve multiple processing steps. For example, the cross product. Recall the formula for the cross product between two vectors. There are three distinct calculations that need to be done, one for each of the different vector components. Algebra like this is prone to mistakes because it's tedious and it's repeated algebra, and so I, for one, routinely make mistakes with the cross product and have to go back and correct it. This is a perfect time to write a function to alleviate this problem. We start out with the function wrapper that we've discussed before. This time the output will be a vector, which we'll call the output vector. The function name can be cross product with two vector inputs v1 and v2. Then in the first line, we calculate the x component of the cross product, then the y component, and then the z component. And the last line is to package all three of the components together in one vector. To test this function, we'll evaluate the cross products between the three direction vectors. First, we have to define each of the vectors. Then we call the cross product function using I and j first. If you recall from previous classes, we know that this should produce the third direction vector k hat. And sure enough, it does. Now let's test the cross product between j and k, which we know should be equal to I hat, and as expected, that's what it produces. And finally, let's test the cross product between k and I, which we know should equal j hat. And just like the others, this too is exactly what we expect it to do. In summary, named functions have large bodies of code to modularize complex portions of code. Anonymous functions, by comparison, are stored in a variable. They have one line of code and are used for very simple operations, whereas named functions are stored as .m files. They can include infinite lines theoretically, and they are used for complex operations. The syntax includes the function and end keywords, as well as the output specified in brackets, function name, and the input specified in parentheses. And it's good to use a named function for extracting repeated complex operations, in particular when a bit of code requires several steps to complete. After defining the function inputs and outputs and its name, the code solves for each component of the output vector as distinct steps for the cross product, and then it combines each component into one vector and returns that to the main body of code.